All right, graphs in 3 dimensions. Right here, this is what we've done before, graphs in 2 dimensions. This shouldn't look new to you. You have your x-axis and your y-axis. Now, when you look at graphs in 3 dimensions, this is what it looks like. Okay? The black is what you're looking at. If you think of it 3-dimensionally, right here, the x-axis, this one, is coming forward and backward, not up and down. All right, forward would be your positives, backward would be your negatives. All right, your y-axis would be the horizontal, right here, and positives would be to the right, negatives would be to the left. And your z-axis would be here, straight up and down, and the positives would be up, and the negatives would be down.
So the only difference is the x.
The x is now coming forward, coming out at you, like this. Okay? Good? Yeah, you've got a z in there now.
Where
What's
we
the
get
point
used
of
to
this?
real life.
All right,
What's the point, like, what is
That's a good
this?
one, Johnson.
we're getting there.
Stupid shit.
The heck?
All right, so if I told you
That looks pretty cool.
to plot a point in 3 dimensions, 2, 2, negative 1, plot the point 2, 2, negative 1, means the 2 is the x, the 2 is the y, the negative 1 is the z. So you got to think 3 dimensions. Positive 2 means you go forward 2 on the x, okay, 2 to the right on the y, and down 1 on the z. Okay, I just use lines here to show how we got there. You don't have to use the lines if you don't want to. The only thing that you need in your answer is the point, the actual point. We're plotting a point just like we did in 2 dimensions. If I plotted the point 2, 2, I went right 2, up 2, put a point. The point is your answer, not the lines of how to get there.
Oh
Okay.
my gosh.
Corey, what's your question?
Ready to go. Why are the lines on the y-axis going diagonal?
All right, that's a good question. You have to make sure when you draw this x and y axis to draw the marks right here on the y-axis, they have to be drawn diagonally parallel to the x-axis to show 3 dimensions.
Okay.
Same thing with these. They are drawn horizontally. That one didn't come out too well. But they should be parallel to the y-axis, again, to show 3 dimensions. And this right here on the z-axis is showing 3 dimensions. So when you draw this, huh?
You have to put the little mark on the z-axis.
Yes, because that's showing 3 dimensions. Okay, you got to think of this. It's very important that you actually see it and think of it 3-dimensionally. Okay? When we just did the x and y, you just had to look at it because it was in 2 dimensions.
I still don't
This
see-
is 3 dimensions, just when you, like when you draw your box. Let me draw a box up here.
Can you provide us with graphs that are already like this so we don't have to waste our time drawing?
Look, when I draw this cube, you're looking at that cube in 3 dimensions. Okay? You either see the cube coming out at you, okay, out towards the front, or out towards the back. You can switch it mentally, where this could be the front coming out at you, or this could be coming out at you. Okay? But that, now you're looking at it in 3 dimensions. You guys see your coordinates here as 3 dimensions as well. All right, so just know, now the first thing I would ask you about this point is to describe it without actually graphing it. So if I told you to describe the location of 2, 2, negative 1, you would say forward 2, right 2, down 1. That's all you would have to say. So for the x-coordinate, it's either forward or backward. For the y, it's left or right. For the z, it's up and down. Okay?
So forward is towards us?
Forward is towards you. This is coming towards you. So that's the positive, that's the negative. positive, negative, positive, negative.
I still
Okay.
don't see how you graph it, but,
We'll get to another one.
What was for the Z?
Z was up and down.
Uh,
Alright, so Remy, right here. Positive 2 means you go forward 2 on the X. Okay? Positive 2 on the Y means I go 2 on the Y. Now notice where it puts me though. If you're thinking 3 dimensions, it puts me in line with this. So it puts me right here, not here. Does that make sense? So again, we got to think 3 dimensions. And then down 2, I have to come down 1, 2, which would put me here.
I just don't get the down part.
Okay, the down part is the tricky part. See, I'm right here on the Z. So if I go down 2, 1, 2, but I have to be in line with this.
What?
I have to be in line with this. Because again, 3
You didn't go
dimensions.
down to, Mr. Turner.
No, I went down 2. If I'm here, I've got to be in line with this.
Then why is why is y negative 1 and you're going down 2?
Wait a minute. What?
Not
You good?
No.
Alright, let's look at
So
another.
is the X is the one that way. Is that lined up pretty much the same way? Because it's
Okay, we'll look at another one.
You didn't go down 2, you went down 1, no 1.
Yes.
You just said you went down 2.
No, I went forward 2,
And then
Right
right 2.
right 2,
And then down 1.
and down 1.
Okay, you just said you
What
went
did I
down.
say?
You said you went down.
Down.
Okay, I should have said 1.
Okay.
Okay? Alright, now let's look at the next one.
Wait, Coach,
Yeah.
did you have to put a dot when you graph the Y? Or you don't have to put a dot where you graph the Y?
Your dot is your final answer. You're plotting a point here. The red is my answer. I don't need to see the blue here. The blue is just showing me how I got to that point.
So,
Okay? The red is your final answer.
okay.
Okay? If you want to draw the lines, that's up to you. Now the next example, I think you'll like it a little bit better. Sketch the graph of 2x plus 3y plus 4z equals 12. All I have to do, this is in
that
standard form.
form?
This is in standard form. All we have to do is find the x, y, and z intercepts. Remember, to get the x-intercept, what are your y and z values? 0. So we can basically ignore this and solve for 2x equals 12. So what's your x-intercept? 6. So you put a point at 6 on the x-axis. 1, 2, 3, 4, 5, 6. Same thing for the y-intercept. It should be 4. Put a point at 4. And the z is 3. 1, 2, 3. Connect those 3 intercepts with lines. And the most important area is your shaded region. So right here you have to shade inside the triangular region because every point you pick inside that triangle would be a solution.
This is ridiculous.
Okay? We got it? Any question?
Are you always going to shade? Or sometimes
You always have to shade the triangular region.